from forming with an interface by enabling an authentication password for each of these interconnecting interfaces. Once we set that up at the interface level, then let's go configure authentication between all the routers here in Area 100, between R1, BB1, and BB2. Let's set up area authentication, and then between areas, between R1 and R2, let's set up domain authentication. First, on router R1, let's get back into global configuration mode. Let's go into interface configuration mode for interface serial 0/0.1. And we want to give an authentication password for this interface. That's going to have to match the password given at the far end of this link on router BB1 in this case. We're going to say ISIS password, and let's give a password of Cisco Press 1. Let's go do the same thing for interface serial 0/0.2. We say ISIS password Cisco Press 1. Notice that there's no need to do this for loopback 0 because there is no other router at the far end of this virtual loopback link. Oh, and we got some interesting information pop up on the screen. We are getting an authentication fail message. And that's because the other end of this link, BB1, has not yet been configured for authentication. Next, let's go into router configuration mode. Let's say router ISIS. And let's set up our domain password, and let's set up our area password. Here's how we do that. We say in router configuration mode, domain hyphen password, and we give a password of, let's say, Cisco Press 3 for the domain password, and we say area password, and let's give an area password of Cisco Press 2. I think we're done with our authentication configuration on R1. Let's now go over to router BB1, and on router BB1, let's go into interface serial 0/0.1. And let's say we have an ISIS password of Cisco Press 1. Let's do the same thing for serial 0/0.2. We have an ISIS password of Cisco Press 1. And in router configuration mode, we say router ISIS. Let's configure the area password for all the routers within Area 100. We say area password Cisco Press 2. No need to give a domain password on BB1 because it is just a level 1 router. It's not a level 2 router. It's not talking to another area. So there's no reason for this to have a domain password. Next, let's move over to router BB2. On router BB2, let's go into global configuration mode and then into interface serial 0/0.1, and let's set it up with an ISIS password of Cisco Press 1. Let's do the same thing for serial 0/0.2, ISIS password Cisco Press 1, and we go into router configuration mode and we say area password Cisco Press 2. We have one more router to configure, and it's over in another area. It's router R2. So let's go over to router R2, and on router R2, we're not really worried about configuring authentication for an interface within this area because we really don't have any other routers within this area. What we are concerned about, though, is domain authentication. So let's go into router configuration mode by saying router ISIS, and let's give the command domain password Cisco Press 3. That's our domain password. At this point, we should have successfully completed our authentication configuration. Let's make sure that we do have reachability throughout the network. From the perspective of router R2, let's do a show IP route. And it appears that I do know how to get to each of the other routers. I can see everyone's loopback interfaces. Let's verify this with a few ping commands. Let's do a ping to 1.1.1.1. Successful. Let's ping 2.2.2.2. That's ourselves. Let's now ping BB1 at 3.3.3.3. Let's also do a ping over to 4.4.4.4. That's BB2. And that's successful as well. I'm curious, though, as to what sort of ISIS information has been learned by router R1, for example. Let's go over to router R1, and let's issue this command. Let's say show ISIS topology. Show ISIS topology. Notice what this is telling us. It's telling us about our adjacent level 1 routers. BB1, BB2, those are level 1 routers. It also tells us about router R2. That's an adjacent level 2 router. Another show command we might want to give for verification purposes, we could say show ISIS host name. And this is going to tell us the system IDs for all of the routers in this ISIS topology. Remember how we made the system IDs reflect the IP address of each router's loopback 0 interface. One other thing I'd like to point out, let's go over to one of these level 1 routers. For example, let's go over to router BB1 and let's do a show IP route from the perspective of BB1. Something I'd like to point out is we do not have an explicit route entry on BB1 for the loopback interface on router R2. We do not have an explicit entry for the 10.1.2.0 network. These are networks that live in another area, and BB1 is a level 1 router, but we do have reachability. We absolutely can get over and ping 2.2.2.2. How's that possible? Well, look at this one entry. We have a default route configured. You see this? We have a default route configured that's pointing us over to router R1. R1 is telling the level 1 members of Area 100 that if they want to get out to a different network outside of this area, they can forward their packets to router R1. Well, that is going to conclude our configuration of ISIS routing. In this lab, we were introduced to the ISIS routing protocol, but we mentioned that ISIS by default does not route IP traffic. However, integrated ISIS does. So that's what we focused on. We focused on the configuration of integrated ISIS. We saw that we could go in to router configuration mode for the ISIS routing process, and we could specify an INSAP address to identify the system or to identify the router participating in ISIS. We could then go into the various interfaces and say that these interfaces were participating in ISIS, and we saw that much like an OSPF network could be divided into areas, an integrated ISIS network that could also be divided into different areas. And we took it a step further. We set up some authentication. We set up neighbor authentication between neighbors forming adjacencies with one another within an area. We set up area authentication between all of the systems or all of the routers within an area. And we set up domain authentication between different areas. And we configured this on routers R1 and R2, acting as level 1, level 2 routers. Coming up in our next lab, we're going to see how we can have a finer level of control of how our routers are going to route traffic using something called policy-based routing. That's coming up in lab number 9.